So I had to redo it.
Alright, so our special cases, we're going to cover 3 types of special cases. These are meant to make factoring certain polynomials easier. It's very formulaic. You're going to have to memorize the formulas. They're not that hard. Every time you use one, I recommend writing out the formula as it is before you fill it in and use it. That's going to help you memorize it a lot faster. Okay? First one we're going to talk about is perfect square trinomials. When we did multiplication in second quarter, I told you that this stuff was going to come back around, that we would get special products. These are the special products. Okay? So now what we're doing is we're going to take a perfect square trinomial and we're going to break it apart into a binomial square. Okay? The factoring gets really easy. The hard part is checking to see, is it a perfect square trinomial? For the beginning, when you see a trinomial, you're going to know it's going to be a perfect square trinomial. Okay? But once we start mixing it in with all of our trinomials, then you're going to have to make sure you go through the process of verifying that it is a perfect square trinomial. You need to get in that habit. You need to do that check. That's pretty much the only work I have to see when you factor them, is like proving it's a perfect square trinomial, which takes 2. After that, the factoring takes 5 seconds, and that's not an exaggeration. Okay? So what we're looking at is we have the first and last term of our trinomial are perfect squares. Let's talk about what perfect squares are. Numericals. Numerical perfect squares. 1 squared is 1. 2 squared is 4. 3 squared. 4 squared. 5 squared. 6 squared. 7 squared. 8 squared. 9 squared. 10 squared. 11 and 12 squared. Those are the most common ones that you'll see. Ingrain that list in your memory. Because in your head, it says, hey, those are perfect squares. I might have a perfect square trinomial. A follow-up step that goes with it. You also have to keep in mind the variables, exponents. If you have a variable with an exponent, perfect squares are even exponents. Any even exponent is a perfect square. Okay? Any even exponent will be a perfect square. To square root an even exponent, you divide the exponent by 2. So the square root of x squared, 2 divided by 2 is 1. The square root of x to the 4th, 4 divided by 2 is 2. X to the 6th, square root is x to the 3rd.
So any even one?
Any even exponent would be a perfect square. Okay? Once we verify that those are perfect squares, what we're going to do is we're going to square root the number, we're going to double it, and we're going to make sure that it's the same as the middle term. If it is, then it's a perfect square trinomial. If it's not, then it's not. A couple other things to note. The last symbol is always plus. Okay? It's always plus than whatever your third term is. Always plus. The first one can be plus or minus. And that plus or minus will match with the factored form. But the last one always has to be plus. Okay? And like with all of our factoring, check for a greatest factor first. Always check for a greatest common factor. If you don't, you're screwing up the whole process. Find your GCF first if you have one. Most of the time you won't. But when you do, you need to find it. Okay? No GCF. So we're looking at our terms. First and last. Are they perfect squares?
Yes.
Yes. So square root them. What's the square root of x squared?
4.
The square root of x squared. X. Square root of 16. 4. Okay? So now what we need to do is we need to check, is it a perfect square trinomial? So this step is really important. We're going to take both of these terms. 4 times, or so x times 4, and we're going to double it. We're going to multiply it by 2. What's x times 4 times 2? 8x. Is that my middle term?
Yeah.
So that means yes, this is a perfect square trinomial. Once we've done that check, and that's all the work I need to see for your check, the factoring will literally take 5 seconds or less. Are you ready? Don't blink, or you will miss it. Go for it.
X plus. That's it.
No, I'm not done yet. I'm waiting.
Plus.
Parentheses. Squared. That's it. Plus parentheses squared. Done. Square root the first and last. Check to make sure that the product of those two times 2 is your middle term. If it is, you're going to use the first symbol, plus or minus, parentheses, squared, finished.
Okay, so let me run it back really fast. So the x, you factor it, so it's going to be x.
I square rooted it.
Yeah, square root, sorry. And then the 16.
Square rooted it. Says it needs to be 2 times the product of those. So I multiplied them, and I doubled it, and that's my middle term. It's that pattern. Because look at when you expand, okay? And this is why the pattern kind of shows up. And we talked about this a little bit when we dealt with a binomial square. Okay? When I distribute here, right, I'm going to get my x squared. I get plus 4x plus 16. So I have 4x twice. 4x twice. So as long as it fits that pattern, then we know it's going to factor to be a squared binomial. That's why they're called special cases, because they fit a special pattern and they're easier to factor if you see that pattern. Let's do it again. Perfect square?
4.
Yeah. What's the square root?
X.
4x. Perfect square?
Y.
Y. This is the square root. So 4 times x times y times 2.
4x, 8xy.
Is that my middle term? Yeah. That's fine, because that negative is going to go here. Done. Because remember when we distribute, see I have the same term twice? I have 2 times 4x. So I have 2 4x. So the formula is 2 times the product of the terms. Perfect square trinomials. So the biggest thing is, once we start adding in our other trinomials that we're used to seeing for the first couple sections, they're not all going to be perfect square trinomials. So you need to recognize perfect squares. And so when you see them, okay, also you have to check for your greatest common factors. Sometimes there's a GCF, and they don't start out as perfect squares, but if I factor out a GCF, then they become perfect squares. So you need to be aware of those. Always checking for a GCF, and just always looking, do I have perfect squares? And the perfect squares are going to show up again, too, for the next one. All right, our second special case is a difference of squares. Okay, first of all, they're only binomials. So all we have to do is check that both of our terms are perfect squares and that they're being subtracted. Take your iPad, you don't focus. Both of these are perfect squares and that they're being subtracted. Okay, difference means subtract. Okay, the way that it factors, it's always going to be 2 binomials, 1 plus, 1 minus, and I'm using those square roots again. Okay, so let's look at our difference of squares. Perfect square?
X.
Perfect square?
4.
So I have x and I have 4. Write it again. Put them in parentheses.
Oh my God.
Plus and minus. That's it.
I thought you said the plus always went in that.
Focusing, instead of giggling over there, you would have heard that. Special case, difference of squares. First one was perfect square trinomial, now we have a difference of squares, something different. Okay? Go ahead and write all your parentheses. Alright. For B, 3x. Yeah. And 2. That's it.
Dude, I'm gonna get 100. So it's gonna be 3. It's not or 4x.
pass your exam and graduate high school.
Wow. Sounds like a blast.
What if I don't want to graduate?
Yeah, what if
That's a choice you can make.
I want to stay here forever?
No, I'm joking.
That gets really expensive real quick.
I want to go out here.
Been here for longer than
Picture of you in the middle school.
They cut me out of that picture. Is there
Giant picture of you in the middle school.
where? They cut it out.
In like
a lot in
that
that
first
picture.
hallway.
Really?
Yeah.
Downstairs?
Yeah.
Manuela.
They cut you out?
Manuela, it's the picture of us from when we did the
Oh, it's also on the website for the middle school, right? Yeah.
They cut me out of
Yeah.
it. Oh.
Alright. What did I say about exponents in order for them to be perfect squares? They have to be even. Okay? So, x to the 8th, y to the 6th, those are even. So they're perfect squares. So what did I say was the square root of x to the 8th?
X to the fourth.
X to the 4th, divided by 2. So x to the 4th, x to the 4th, if I could write, boom, 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 okay? Square root of y to the 6th, y to the 3rd,
Plus minus.
third, 1/3, plus, minus. Easy peasy.
Wait, what hallway are we talking about?
Go into the left, walk down by the study hall. Write this down because I'm moving to the next slide.
Is it always?
You could write it the other order if you want. You could do minus plus.
16, 6, 36.
The only thing you can't change the order of is the terms because the order for the minus makes a big difference. So you can't have y to the 3rd minus x to the 4th. That changes it. Okay?
Only 6 questions.
You want more? I think I'm going to do that.
Let's see.
Yeah.
You already did.
No, I think I'm
No, I didn't actually do any bad. No. But
Alright. Perfect square.
X to the second. Minus 9.
Plus 9. Plus 9 minus and then x to the
X to
second.
the second. This is where I can get really tricky.
You know, you just did plus 9.
No, you don't square it.
I know.
Nice. You mean X squared? Yeah. We got this. We were really. Alright. Time to start the homework? Go, we're not. We're not done.
Did you know you could
Look at it. No. It's special. Why is it special? Huh?
Because it's not a 2. I know.
I literally just couldn't
Because
hear
you
you.
can simplify it
By doing what?
by doing
Square.
Square on the
Okay.
outside. No, x plus 3.
No, x minus
I'm
x
taking
plus
up what you're
3
setting
squared.
down.
Why
No,
squared?
I don't get it. Let me have it. Oh, because you can
Okay.
simplify it again.
It's
Yeah,
another
That's
difference
what I
of
just
square.
said.
I know. That's why I wrote it down.
There's no.
It's another difference of squares. So I need to factor it again and bring down
You have to bring down those.
the other one.
What?
Wait.
Why'd you do that?
Yo, what?
But couldn't you leave it as x to the second plus 9? I'm so
So the directions will always say factor completely. So if you're left with something that can still be factored more, you gotta factor it more.
But I have to rewrite it like that with the 2 to the second plus.
X squared plus 9, yes. Because this is still part of your original polynomial. It's still there.
Yeah.
I should be able to multiply all of this together and get back to x to the 4th minus 81. So if I leave this out, I don't get back here. Okay? And on the quiz yesterday, a lot of people left off common factors in the answers. You factored it out, I saw it in your work, but when you wrote your final answer, it wasn't there anymore. So you lose points for that. So if you have to continue factoring, whether it's factoring out a common factor, whether it's multiple steps of using some factoring, if it gets factored out at some point, it still needs to be in the final answer. Because you need to be able to take all of that, multiply it back together, and get back to the original expression. Okay? So I got x squared plus 9, I got x squared minus 9. I can keep going with the x squared minus 9, but x squared plus 9 is still part of my solution. It still needs to be included in the answer, along with the additional factorization. You got to keep that in mind. Okay? My recommendation is when you're factoring, if you factor something out and you're done with it, but you have to keep going with something else, go ahead and write that on your answer line to start and then fill in the rest of it when you're done. That way you don't forget. Because those GCFs disappear all the time. All right, 36x squared minus 64. So 6x plus 8 and 6x minus 8. Okay, why is it 3x plus 4? I can do what? Nope, what can I do? Why? Why does it become 3x plus 4? How? Factor out what?
It's going to be 6x plus 8 and then 3x plus...
Where's the 3x plus 4 coming from? What are you factoring?
You're simplifying 6x plus 8.
Factoring out what? 2. Your common factor. Now I have to do it from both of them, right?
No.
Yes, I do. Now, what I want you to look at, I have to factor that out from both.
I thought you had to keep 6x plus 8.
Both of those have common factors in them. This has a common factor of 2, and this has a common factor of 2. I need to factor it out of both. That's starting to get confusing, right? So we're going to scrap this. We're going to go back to this again. Our common factor for 36 and 64. What's the greatest common factor? 4. Factor out a 4, and I'm left with 9x squared minus 16. Still a difference of squares, but leads me to these two. Factor out your GCF. Even if it already looks like a perfect square. And it is perfect square. But you need to factor it completely. Always check for a common factor first.
Wait.
Yeah, so then last time, for the last equation, why did we keep the original equation? And then
The only thing, these don't have a common factor. The only thing I can do is factor the difference of squares. And then this one just happened to also be a difference of squares, which required an additional factoring. These had a common factor from the start. Okay? These had a common factor from the start. You could stick with this, that's fine. If you wanted to have this, all you have to do from this point is just realize you can multiply 2 and 2 together, and that still gets you here. But if you check for the greatest common factor first, you get that out of the way, as a general rule of thumb, the process is easier. Okay? Alright? Last one we're going to cover is sum and difference of cubes. So I want to make this very, very clear. So pay really close attention to what I'm about to say. When we have perfect cubes, not perfect squares, perfect cubes, we have formulas for sum and difference. We have both. There is no sum of perfect squares. Notice how the perfect squares is just 1, the difference, and that's it. I didn't factor this sum of squares because there's no factoring squares, sum of squares with real numbers. It's not going to happen. Okay? But when we have cubes, I can do plus or minus. Okay? Let's talk about perfect cubes. Okay? Exponents are multiples of 3. Multiples of 3. So if it's a multiple of 3 for the exponent, it is a perfect cube. To cube root it, you divide the exponent by 3. Okay? Note, these are also what? They're also perfect squares. So some of them will be perfect squares and perfect cubes. There's also some numbers that are both. 64 is a perfect square and a perfect cube. It's 8 squared and it's 4 cubed. So you need to be aware of some of those little nuances and kind of look at the whole picture and make sure you're using the right formula. Perfect cubes, numbers that you're going to see a lot. 1, that one's easy. Okay. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. Those are the ones you'll see the most. Could you get ones higher? Yes. But those are the ones you'll see the most. Okay? So these are what we use for different cubes. And then we're going to follow a similar pattern that we've been doing. But instead of square rooting the values that we get, we're going to cube root the values that we get. And we're going to plug them into these formulas. Couple things to note about these formulas. Again, you're going to have to memorize these. I'm not giving them to you. But when you've got them, they're very, very similar. The first sign always matches. Okay? First sign's always the same. The second sign always switches. See that? The second sign always switches, and the last one is always addition. Okay? So let's use it. It makes it a little bit easier. All right? Really easy sum of cubes to start with. X cubed and 1, the most basic cubes we can get. The cube root of them being x and 1. Okay? So our formula for a sum of cubes is a plus b, a squared minus ab plus b squared. Okay? So let's break that down. When I cube root them, okay, that's what these are. Those are the cube roots. That's my binomial with a plus sign in it. Boom, that's my binomial. Okay? So I have x plus 1. That's where I'm starting at. I cube root the numbers, put it in my binomial, matching the sign. Yep, that's a plus b. Okay? And then just take it, use these as your reference point for the rest of the factoring. Okay? For the rest of it. So I'm going to take a and I'm going to square it. So if I take x and square it, what do I have? X squared. I'm going to take a and b and I'm going to multiply them together. What's x times 1? X. Now it's going to be a subtraction sign because it's got a switch. And I take the last one and I square the number. What's 1 squared? 1. Done. That's it. We'll do another one and you'll see kind of some of the differences.
Where'd you get?
First number squared. Okay, so x squared. I multiply the two terms, x and 1. Thank you. Negative because the sign has to switch. That's where I got that from. And then 1 squared is 1.
Where did the negative x come from?
The formula. Minus
Oh,
the
that
first
there
term.
shows the formula?
That's the formula.
Oh, okay.
Yeah, that's the formula.
So let me just write that.
You plug it in.
So for the actual.
I'm not giving you the formula.
So we have to remember.
Yes. Memorize them, and then when you get your test, write it down. Okay?
Oh.
Oh, God. Okay? Perfect cube, right? Cube root is x. What's the cube root of 27? 3. Okay? So again, our formula, a minus b, a squared plus ab plus b squared. And when you're doing your homework, just write that down. Every single time that you need it, write it. And say it out loud while you write it down.
Wait. So the a minus b is going to be a
It's plus because this is plus. It's minus because this is minus. Okay? So there's my binomial. So I'm starting with x minus 3. There's a whole lot of side chatter going on for the fact that I'm talking right now. So that's my binomial to start. Everything else, I'm going to base it off of this. So a squared is going to be x squared plus multiply the two together. Square the second one. Always plus. Always plus.
And the other one we did minus.
The second one is the last sign is always plus.
So the last one, it's 3 times 3.
3 squared.
Alright, let's go.
Alright, last one.
What do I have?
64. So, 8.
Nope. That's the square root of 64. Cube root of 64 is what? 4. 1, 2, 3, 4, 5. Okay. So, square root of 64 is,
4y to the 3rd.
well, if I'm cube rooting it, it's y. Well, let's, you know what? Let's go back a step. We're missing something.
What are we missing?
That's what I'm asking you. What are we missing?
We need
By doing what?
by
Nope.
getting rid of the y3.
Factoring out the y. It's a perfect cube, which is fine. So we can still use it in the formula, but then we're going to factor it out again anyway. So factor it out now. Make it easier. Factor out y to the 3rd, and that way we're left with 64 minus x to the 3rd. Now cube root these. I've got 4, I've got x, and we're going to use our formula a minus b, a squared plus ab plus b squared. So what's my binomial going to be?
16.
A
4 minus
b.
x.
Good. 4 minus x. Now, square the first one.
16.
Multiply the 2.
4x.
Square the second one.
Plus x.
Is that good?
Yeah, 4. And you go
Bring the y down.